here today with Lisa in Scansite 3D. Some exciting technology to discuss today. So, Lisa, tell us a little bit about what we would really love to hear, and I know your audience really wants to know. Going back 25 years, 3D scanning, what was it like being in this technology back then?
Yeah, well, it was kind of painful. You know, this was pre-internet and pre-PC, so everything was done with SGI computers, Silicon Graphics, and on the command line. And so, you know, nobody really remembers what that
command line is, yeah.
But, yeah, I mean, I can remember taking a Fortran class in college, and after 3 days said, out of here, you know. It was crazy. So because you have to say, if you wanted to copy something, you had to type in CPY and then the name of the file and then, you know, PST or PT. I don't even remember all the codes now to get something to cut and paste, just even, you know, to the next line. It was crazy. But, you know, we fell into this through a woman that we met who was a furniture designer, and she was hand sculpting furniture in these organic designs, and we had to figure out how to manufacture this stuff. And you can't organically design in a computer, so somebody, a guy that we met that we were buying materials from, told us about scanning. And this was something that the military had developed to scan targets after they blew them up and see how they worked. And we met this guy who happened to be in Monterey, California, a guy named David Adelman. And he was an inventor, and he lived up on this house, this fabulous house, very eclectic house up in the mountains outside of Monterey, beautiful view of the ocean. And oh man, he looked like Henry Fonda. He wore this hat on his head, and he had all these fishing lures all around it, and his house was solar, and there was, you know, this was
solar 25 years ago.
25 years ago, and his electric was solar, and this big, beautiful house. Only about half of it ever worked, but he introduced us to it, and we saw this happening. It was very rudimentary, but we saw him take a scan of actually a person, and we couldn't believe it. It was like the Starship Replicator. It just instantly appeared on the screen, and then he could manipulate, turn it around, and couldn't believe it. And I said, well, we're getting involved somehow. I don't know how or what.
How many people back then were even involved in that technology?
Well, the Adelman family, he had his son working for him, and then he brought his other son in, and his daughter eventually came and worked with them, and they were a small company called Cyberware, and they're gone now. But it was there was a handful of us worldwide. There was a guy in Australia that was coding some software to try to stitch individual scans together into a single description. And there were maybe less than 20 of us, I suppose, worldwide. And it used to take 6 weeks to hand merge 4 individual scans together, and now we routinely do, you know, 250, 300, 400 scans, you know, in one session. So
that's incredible. Just to be part of such an amazing technology from the beginning, it really must give you some great insight of the whole industry.
Yeah, and what's changed now, and 3D is really alive and well, and it's being incorporated in every single industry. And the big game changer was hardware. I mean, the computing power, and that's what's really
the processors you thinking, or storage
power.
Process.
Both, but primarily processing power and graphics cards. So, you know, computers have gotten so much more powerful now that that you can run with scan data. I mean, generally scans are very large files. And in our business, we like to say you can't have too much data.
Right.
Because we'd rather have it and then be able to decide whether or not we're going to use it all. And it's not like we're going to pass off a 5 gig file to somebody, but we'd like to get the information and have that option.
Well, I know that you mentioned dealing with gigabytes years ago. So today, a 5 gigabyte file is large, but it's something that is more reasonable.
Exactly.
But
yeah,
10 years ago, 5 years ago, did you ever have to deal with any files that
boy.
large? Or
we sure did.
and how would you? I mean, I can't imagine 10 years ago dealing with the processors that we were generally seeing, dealing with a multi-gigabyte file.
Yeah, multi-gigabyte, and we would get at that time, 5 or 6 gigs in a project, and really had to struggle to try to process that. And we were using the Silicon Graphics computers, and they generally cost anywhere from $80,000 to $100,000 for a computer. And you would set it up and get it processing the scans, and it would just sit there and crank all night, and you just pray it didn't crash. It was kind of crazy. I mean, most recently, just a couple weeks ago, we produced a file that broke an all-time record for data. It's 100 gigs of information.
Wow.
And we said, well, I guess we got to get a bigger computer. But it was the recent project with the Smithsonian, with the 37-foot long T-Rex that's standing on a Triceratops that's laying on its side, and they're kind of in a fighting pose. And we scanned that, and that was 100 gigs, and we really
100
really
gigabyte.
Kind of
That's incredible.
Yeah.
So that sounds like an exciting project. Did you have to tell us a little bit about that? I mean, that must have been a gigantic project, not just file.
Yeah, big project. So this is kind of fun. We've been working with the Smithsonian for some time, and they, of course, house the nation's treasures, and they're really trying to make these treasures available to everybody across the country and indeed across the world. And they know that a lot of people will never get to Washington, D.C., or won't have access, and they really want to turn on kids, and have schools have access to this. So they have, in the last 5 years, built an online viewer for 3D files that is probably the most powerful I've seen. And we are scanning different things from the African American Museum, the Natural History Museum, quite a bit of vehicles from the Air and Space Museum, and they're putting these online in 3D in full color. And so at the moment, I think there are probably about a dozen models up there, but probably by the end of the year, there'll be, hopefully 50 to 100. And we're choosing some high profile things to put up there first to kind of kick off the project. So the Apollo 11 space module's up there, and you can actually turn things around and zoom in and see the tiniest little detail inside the space capsule. You don't need a VR headset. You don't need any special software. You just click on the web page, and these images load, and the 3D files load, and lets everybody access them.
So what was this website again, or do you know the actual?
It's if you Google, boy, I should look that up. The Smithsonian Digitization. So just Smithsonian 3D Digital, and you'll see some things that pop up. It is online, but I don't know what the name of it is.
And maybe I'll do some research and get it, and we'll put it for the audience to see. We'll make sure we get it up there. And
it's
get
very, very cool. Yeah.
Yeah, that sounds awesome. And some of the things that we were talking about earlier, going back to the dinosaurs, is just, well, the one thing that I've always felt about businesses like yours is how much impact you guys get to have on the world. And one of the things that you were talking about is you did a scan for some dinosaurs back a while before this project, and how you had taken what they had thought was one animal, but by the time you got done scanning it, there was evidence of 16 different animals. For me, that's such an impact that impacts the world. It makes us better in so much more understanding. Can you tell us a little bit about how you've seen that kind of transform from that dinosaur to now getting to work with, the Smithsonian, and with it being so much available to the public?
Oh, sure. Yeah. These are the wonderful things that technology is kind of bringing, to the world with a better understanding, creating a better understanding of our world around us, and also bringing us closer together as a community, worldwide. And that was a case. This was we were brought in by the Smithsonian to scan the first dinosaur that was ever found and mounted, and it was discovered in 1898 and mounted in 1904, and it was a Triceratops. And when they found it, it was just a mosh pit of different animals, and they really didn't know what they found. No one had ever seen any of these, so they the paleontologists dug the bones out of the rock, and then they took them by mule and cart to the closest train station, and the trains were just coming online, and there was now a cross-country train, and they sent them back to D.C., and they continued to remove the bone from the matrix and put together the first dinosaur. And they did the best they could, and it was a pretty incredible feet at that time, and then all this time later, they had us come in and scan this. So we scanned the Triceratops in its entirety when it was put together, and then the paleontologists took the bones apart, and we scanned all 284 bones, and then we digitally, using the overall scan as a template, reconstructed the dinosaur in its entirety in the computer. We were still using silicon graphics at the time as well, so there was lots and lots and lots of number crunching. And this was such a new thing, and it was such a novel idea to try, that they actually set us up in Dinosaur Hall and had us work there for 6 weeks, and invited visiting researchers to come and ask questions and allow the public to watch and ask questions. And they basically put us on display while we were working. And so when we put the dinosaur back together, another brand new technology that had just came out was 3D printing. And there were 2 3D printers in the country. And one was owned by Hasbro Toys, which happened to be a client, and the other one was owned by an aerospace company that also happened to be a client. And so we decided that we could make a scale model of the dinosaur. So we scaled the Triceratops down, and we made a 3-foot version out of the 284 bones. And Hasbro Toys very graciously donated the model. And then the Smithsonian pinned it all back together, just like the original mount, looking like the original mount. And then they did biomechanical studies on that dinosaur. And that was the first time that any biomechanical studies had ever been done on a dinosaur, because they're too heavy to move around and play with. And then we recruited an animator from LucasArts that was also, Lucasfilm was also a client. And they brought that dinosaur into 3D Studio Max, which is still used today, but it's kind of an old school animation program. And we made that thing move, and we had it walk, and it was amazing. And we plugged in the biomechanical studies kind of conjectures that the paleontologists had came up with. So that was very, very cool. And then the other thing that came out of that is is that we realized from taking dimensions off of the various parts of the dinosaurs and the ribs and the feet and everything that it was actually a conglomeration of 16 different animals. And it had the wrong skull on it. That was kind of a big deal. So we got this brilliant idea that we would create a new skull out of 3D printing. So I went to my other client, the aerospace client, and said, hey, do you guys want to make a 3D printed skull? Well, this skull is 19 feet long. And 3D printing is typically done on things that are 10, 12 inches and under. And so they actually accepted the challenge, and we created this skull out of multiple pieces. And we had to build an internal support structure to actually hold the skull together. and then it all had to be glued at the same time, and no one had ever made anything this big. And to this day, I think it's still the largest 3D print that's ever been made. And it was made in, oh my gosh, where the heck are these guys? It was made in, I have to remember, I think it's, what's the big aerospace? Tulsa, Oklahoma. And once it was made, we then couldn't quite figure out how to get it to Washington, D.C. We couldn't put it on a flatbed truck because no one knew how it would react, to
all the road conditions and wind and variables.
And the light, because it's a photo cured thing anyway. It's a light that 3D printing resins are typically photo cured, and so we didn't want it to move and twist and shape, change shapes, and it wouldn't fit in a box truck because it was too big. And so the aerospace client reached out to the military, and the military flew it in a tank carrier. And it went from Tulsa to Ronald Reagan Airport and landed there, and then they put it on a flatbed and drove it to the Smithsonian. And it got this hero's welcome, and they had to shut down the roads, and there was a parade pretty much waiting for this Triceratops skull to go to the Smithsonian.
Oh, this is such an awesome story. I love it.
I mean, and then they used it to create they actually used it as a model to create an actual plaster one that is now the replacement skull at the right scale, and then we also used it to create a bronze of the skull, which is outside of the Natural History Museum there. So,
wow.
Yeah, that was kind of a fun one. We just get involved in some great projects that I love to hang out and hear the backstories of different objects.
Oh, I think anybody would. These are just amazing stories. And,
I got to take my kids when they were little. They came with me to Dinosaur Hall. I used to, I don't have any family out here, so I didn't really have anybody I could say, could you keep my kids for 6 weeks? So I just took them with me.
Oh.
And they got to hang around and run around the Smithsonian. I remember the school saying, you need to stop pulling your kids out. And I'd say, well, that's about as good an education as you can get.
Yeah,
so they're coming.
I would love to see the challenge that they could do to do better education than taking a kid to. I mean, I'd imagine your kids still talk about it to this day.
Well, my one daughter became an anthropologist, and our son is a historian. So go figure. But this one, the cross that's behind you, that is another one of my favorite pieces and my favorite stories. That is the original is made from carved walrus tusk. And the walrus tusk dates to the 11th century or the 9th century. Oh, wow. And they think the piece was carved in the 11th century. And this is the signature piece from the Cloisters Museum in New York, up in Brooklyn. I think it's in Brooklyn. And so the significance of the Cloisters Cross is that when Richard the Lionhearted was captured coming home from the Crusades, this was the main part of the ransom given to get him back. And we were contracted by the Cloisters Museum and Bury St. Edmund's Church in England, which was King Richard's church, and they wanted a copy, a one-off of this cross to display. And at the time, walrus tusk was the most valuable material in the world, and it's so intricately carved. They don't really know how it was carved. It's kind of like a piece of scrimshaw, but much, much more detailed. And there's spaces behind the carving, so they really don't understand who carved it and how they carved it. But it's got all the stories of the Bible on both sides of it. Very, very interesting piece.
Yeah.
Yeah. So, and that's a kind of a reject from the one that was made. And then the Smithsonian, the Cloisters is owned by the Metropolitan Museum, and we do all of the sculpture that's for sale in their catalog. It's pretty much our work. And they loved it so much that it's now, we kind of condensed it down, scaled it down a little bit, and you can buy it from from the Metropolitan now as well. But I love that piece. Very cool.
Just, I've had the pleasure of doing interviews with many business owners, and I think that you probably would be at the top of the best stories to tell. And also, I will never seem to come off of the fact of how much impact your work has on the world. In general, it's incredible.
Well, just allowing people to know these things and these pieces of history are just really important. They just they explain who we are, and they just give us a wider understanding of mankind, really, and the natural world surrounding us.
So 25 years ago, you're one of the first, if not the first, company to really dive into 3D scanning. So we jump ahead a little bit, and today it's probably one of the most relevant technologies where we're going with 3D printing, and obviously the automotive world being one of the largest manufacturing industries in the world. Just and I know that you've gone into that industry. Can you tell us a little bit about just kind of how you've started with all these amazing projects and now leaped into the automotive industry?
Yeah, sure. So we're very fortunate in that we can use the same tools and a lot of the same experiences in virtually any industries, from manufacturing, industrial design, automotive, aerospace, medical device makers, and then, of course, all the cultural heritage stuff that we do that revolves around conservation and replication. And so with the car industry, they, too, have been able to benefit significantly from scanning. And in the old days, a car maker had to think generally 4 to 5 years out when designing a car. From start to finish. And it's very difficult to predict correctly what the public's going to want. And with the advent of scanning, they can now go from concept to having an actual car on the floor ready to drive away in about 18 months. It has sped up the production process that much. Much easier to know where the trends are going.
18 months versus 5 years is,
Yeah.
much easier to stay within the trends that that they want.
Exactly.
Than 5 years. That makes a lot of sense.
And now, car manufacturers have databases, 3D file databases that they can really mix and match. So if you look at any new car today, it kind of looks like, well, the bumper is maybe from this model, and the side view mirrors are from this model, and the curve of the trunk or the front of the car it's all can be mixed and matched, and that's come with 3D engineering. So in the old days you were using 2D engineering, and it was just much more difficult to translate from 2D into these really curvaceous organic shapes that cars have today. I mean, you can be pretty.
So that's one thing with my limited knowledge, understanding from a 2D perspective that when you go to build it, there's many changes that have to be made to actually make it work because you weren't really able to test it. There's a lot of variables that were missed. But with 3D modeling and with 3D applications, that they're actually able to make the wheels turn sometimes in a model before that's ever even made, actually show the action, not just the 3D model. Am I correct on?
Absolutely. Yep. Yeah. You can put 3D models in wind tunnels, virtual wind tunnels, and test them out. You can do finite element analysis to kind of gauge wear and tear on particular assemblies that are inside automobiles. And you can take exact measurements. You can, all your design can happen in 3D so that you can build these assemblies that are just so accurate. And the same with aerospace. I mean, I fly a lot safer. I feel a lot better on a plane. I can remember as a kid when you'd get on a plane and just taking off down the runway, the thing would just sound like it was going to rattle apart. I mean, and it was common that a overhead bin door would just fly open. Yeah.
Yep.
I mean,
I remember that.
Yeah, it's so crazy. I mean, it wasn't even that long ago. And now these planes, because of scanning and reverse engineering and 3D engineering, they are very, very, very tough and accurate and they're just built so much safer. They can tell everything. And then we touched on the driverless car stuff earlier, and that's all happening with scanning because these car companies are actually starting with existing models and retrofitting them with driverless components that they need. And so we will be called in to scan the whole exterior of a car, all the sheet metal. Then we might do the underbody where they'll take off the bumpers. And then we'll do the underneath of the car. So we'll scan, they'll put it up on a lift and we'll scan there. And then we'll scan the interiors with all the trim on and then also with all the trim removed so that we're getting the attachment points and, all the hidden surfaces that they need to kind of fit their components in. And that industry is taking off, really, really taking off.
Yeah, I can.
And driverless planes. I mean, that's happening now. We've done some driverless personal transport vehicles for companies like Airbus. They're big into this. And so with the San Francisco Bay Area, one of the things that they're doing is recommissioning all of the helipads, of which we have numerous ones, and they've been decommissioned over the years. And now they're bringing them back online. And very quickly, you're going to start seeing people commuting in these personal transport devices that can carry up to 600 pounds. There's no driver, and they look like a small plane, but they have internal rotors. They act
Is it
like
more like a drone?
Yes, kind of. It's driverless, and they have they operate like a helicopter, in that they can hover and they can kind of drive straight like a plane, and then their rotors actually flip up like a helicopter, but the rotors are all contained, so there's none of that kind of air displacement like with a traditional helicopter where they're pretty unsafe really to be around one.
Right.
So that's happening, and that will be online probably within 3 or 4 years.
It's just incredible.
Yeah. Firefighting too. Yeah.
Well, imagine the drones can probably get in deeper too.
Way deeper. They don't care about smoke.
Right.
Yeah.
Because now we're controlling it with GPS, not sight.
Yeah. So, and we do quite a bit of traditional manufacturing. We do quite a bit of inspection. So we can scan existing parts and compare the scan data back to the client's CAD file if things aren't fitting correctly, and then we can compare those and tell them where the part is out. That
actually, for a layman like myself, that just really drew a picture that I could really understand. And that's kind of what I've always thought and hear from different engineers and different people on different levels, is that when you are from a CAD, especially in the 2D format, but even in a 3D when you create it, doesn't necessarily mean that in the real world, in the real application, that it is that perfect. And that was a perfect example, is where you have an engineered CAD product come out, and then you go back and scan the actual product, and there's a variation from the actual perfect CAD program created to the actual product specific. Does that kind of make sense?
No, that's exactly it. And we just did a project with another client that made water bottles and such, and they work with overseas vendors both in China and in Mexico, and the bottles were leaking. Very slight, but water is really hard, as any of us that have ever had a leak in our house, try to figure out where the heck it's coming from. And so we were able to scan the existing bottles from both vendors and then compare that to their CAD. And we found deviations in both sides and both vendors, and the deviation was different, so that was interesting. But that's real information. So we can produce this color map that shows the deviations noted on there. And that's something that an engineer can really grab onto and say, okay, now I know where the problem is, because you can't see stuff from just looking at the products.
Right.
So this is what's so great. Even with coming back to the dinosaur stuff, we can see more in the scan data than looking at the actual bone. So we can see how muscles and tendons attached and things like that isn't possible any other way, really.
That's incredible.
So yeah, it's kind of fun. I mean, I love it because every project that walks in the door is different, and and you always kind of have to kind of think about how you're going to approach it, and I always say to every new client, just, well, where do we want to be at the end of the day, and then work backward from there to come up with a reasonable approach within a budget.
You were talking about ligaments and tendons and just the technology of how effective it is. One of the projects that I know that you guys have done that I found real fascinating, and for me, I really believe that we're going from a world from mechanics to science to everything, and really art and creativity is becoming intertwined, and we're really seeing that, I believe. And so when I watched that video on the Rodin collection, the art collection, and then how you guys were able to get involved and then bring Stanford University in, and I'd love for you to talk a little bit about that. I found that very, very fascinating, and I really believe it really also, for a layman like myself, it makes the story much more easily understandable to the general public.
Yeah, so that was a really interesting project, and it started with a Stanford professor. He actually is the head of the College of Medicine, and he was at the Cantor Museum, which has a significant amount of Rodin's in it. In fact, they have the largest collection of Rodin hand sculptures in the world there. And Rodin had a particular fascination with hands, and he really loved differences. So in hands, so a lot of the sculptures there are of his models that he found, where the model had a hand deformity of one form or another, and they're some of them very, greatly disfigured. And so as he was walking through the museum, he basically had an epiphany that he'd seen some of these hand disfigurations in the past, and in some of his medical journals when he was, completing his own schooling. And it dawned on him that these afflictions that he was seeing in front of him were, actually caused by disease. And so the museum, the Stanford College of Medicine called us and said, we would like you to come in and scan these hands. And so we came down and we scanned the hands, and then we gave it to this professor and his graduate students that he was working with. And they actually did some analysis on the hands and did indeed prove that these were made from, these hands were basically modeled after people that had these diseases. And some of the diseases are now extinct, in the world. And so they then took it another step and used the data to teach surgery techniques. And it became about a 2-year process for them to create basically digital software that would allow them to perform surgery on the data that we created, on these hands. And then they had, actually, it was a high school kid, this young gal who was just brilliant, and now she's actually at Stanford. They admitted it, but she got to know Stanford through a summer program, and she was just a brilliant programmer. And she created an app that allowed when the viewer had an iPad and took their iPad and held it over one of the Rodin hand models, the app would actually run through the stages of the surgery that they went through and correct the hand data, like right in front of you. And so they had this on display at the Cantor for quite a while, and the hands were placed on a big turntable with an iPad kind of mounted in front of it, and you could rotate that iPad around to these different hand sculptures and have them transform right before your eyes, from being a deformed hand to being something that had been corrected. It was just an amazingly outside the box way to use data. It was really a cool thing, and for us to have the privilege to be involved with.
Oh, I bet. Just to see art, to go from just a Rodin collection like that to surgery, to an app that really allows us to really see it and see the rewards of the surgery.
Yeah,
just
absolutely.
All of that is incredible. What a great story.
Yeah, very, really fun. I mean, and we love to problem solve. So, it is not uncommon that someone will walk in with a project and say, "Is this possible?" And we typically jump at stuff like that and just say, "Oh, well, I don't know, but we'll find out." And we dive in and see if it is. Because I love the way that people are thinking about how to use this stuff. I mean, I think it's fabulous.
What's your favorite project that you've worked on?
Oh man, my favorite. So many. Well, well, I do have a passion for the cultural heritage stuff, and I feel pretty strongly that we're losing cultural heritage around the world, and that these scans, because they're so accurate, we typically gather data whose accuracy is anywhere from 7 to 12 microns. And I feel like we're losing so much that it's important that these objects are preserved. So maybe I love the Cloisters Cross. I just love the story of it. Sort of like reminds you of King Arthur and the Knights of the Round Table kind of stuff. And then all of the Michelangelos, we've 22 Michelangelos and several Berninis, and we did Degas' 14-year-old dancer. That was a fabulous project. We were fortunate enough to scan Cupid, which is the newest Michelangelo that was discovered in the French embassy a few years back. And, one of the things that comes up when you're scanning sculpture like a Michelangelo is that you can actually see how the carver approached their work, because you can see chisel marks and such. So you can tell whether they were right-handed or left-handed, and you can almost piece together how they did what they did. And, and that to me is just fascinating when, to get these sort of glimpses into somebody that was arguably probably the best sculpture that's ever been born.
Yeah, that's
To be able to know how his thought process. That kind of stuff. I just love that. We've been fortunate to work on the Liberty Bell. So the Liberty Bell has a crack, and it is in the charge of the Philadelphia Museum. And so the bell is scanned periodically so that they can gauge how much that crack is moving and when they need to intervene. So those are the kinds of things I think where it's just a really wonderful use of the technology. And the same with scanning the Spirit of St. Louis, for instance, which is something I hope to be doing this year, a little later this year. And we can recreate the first flight now. So we know what the Wright brothers went through on that first flight. We can actually, put the actual plane into a program and fly it just like they did.
Oh, wow. To me, that's some amazing stuff, because the Wright brothers were not the team of pilots that we thought were the record, the people that were going to invent the first real flight. They were actually I would say the ones that were underfunded, noticed. Nobody really thought that. And so to be able to go back and investigate that area, that must be incredible, because that's one of the stories I've read about all of my life, but it's always been limited. And I'm forgetting the main, because there was a group of people that were heavily funded, really going after it, that weren't nearly as far as the Wright brothers.
Yeah.
But they got all the information. All of the real stories were not on the Wright brothers at the time.
That's true. And there were a lot of people trying to be the first one to be successful. And the same with early flight travel or space travel. This is the 50th year of the anniversary of the moonwalk. And when they were putting vehicles in space back then, the calculations that they were making were done with a slide ruler. And it's just,
and I'd imagine half the people listening to this podcast don't know what a slide ruler is. And I think that makes the point.
I mean, and you really were putting your faith in these engineers to be able to do that. And there was a lot of sacrifice and a lot of life lost with the early space explorers, basically. And nowadays, I mean, with scanning and with the advent of 3D engineering, they're just launching things in space all the time. I mean, it's, in the C section on page 12, because it's so commonplace and it's so different now. But in the old days, oh boy, and that's not even that old. That's 50 years is not really all that long ago.
Right.
But it blows my mind and even early cars and the things that they, sheer perseverance and just gut feelings often about how you would build something.
Right.
And they just, you had a good engineer, and they probably had some, they had a lot of experience they could draw on to make things work. But I mean, now with the tools that we have, you can really have assurances. I mean, you really can test your theories and your engineering work.
We've talked a little bit about where you're going or where you've gone in the last 25 years. I would love to hear, because you're obviously more in tune with technology than many companies, and you've seen the growth. In 25 years, you've probably seen some significant difference. Just listening to you talk about the aerospace world. In just 50 years, we've, changed everything. So what I read all the time is that we're going to have more innovation and more change technologically in the next 10 years than we have in 100 years. You got any insight on that, or any ideas that you see? Because you probably are much more into the future than most of us.
I think that with the scanning and scanners in general are the missing link kind of between the engineering world and the real world, and they connected in a way that's never been possible. And I think that innovation will continue to happen because of these tools, and they're only limited by people's imaginations anymore. It's almost whatever you can think of is possible. I mean, and I do think that
that's a pretty strong statement right there. But I believe you.
Yeah, no, it's happening, and most people, this is sort of flying under the radar, but these are tools that are being incorporated in literally every industry. So
and rapidly.
They're changing our world. They are absolutely changing the
Rapidly.
world. Medical devices too, anything that interacts with the human body. The human body is organic. It's impossible to really draw something in an engineering program that's exact to somebody's body. So now everything could be custom fit right to a person. Prosthetics, it's changing prosthetic world, because if you have a missing limb, you can scan the existing limb and mirror that data and reproduce an exact duplicate that's based on your own body now. And prosthetics in the old days would not fit properly, and they were rub you and create sores, and that stuff is all gone away. I mean, I think I see that as great promise. I mean,
So one of the guys that I'm real familiar with is Dr. Groats, and he's a orthopedic surgeon that really turned into an inventor. And I'm always discussing it with him, and he really feels that a lot of the industry is barbaric in that industry because of the technology. And he's out there every day trying to change the materials and in different aspects of the surgery. So do you see that in just listening to some of the projects you guys have been on, I can see where we might be getting into understanding the bones and really getting more into, because I'm talking like hip replacements and knee replacements. These are very, very sophisticated procedures, and it seems like every month that goes by, there's a new innovation and technology. So I guess my question is, do you see scanning being a big part of that as it grows?
Oh, absolutely. Scanning, 3D printing, it's absolutely huge. And if you think about how much technology is changing and how quickly, when you think of it in the medical realm, it's even faster in medicine that it's changing. Medicine is really doubling its tech in a year. It's pretty astounding.
Wow.
It's definitely astounding, and that's a good thing. I mean, I think about, and there's a couple things we talked about: computing power being a game changer for these tools in this industry. Well, the other thing that's a game changer is that new surgeons and everybody coming out of school are very comfortable working in 3D, and they're very comfortable working in tech. And so that also is changing and leading the charge. I mean, it's, and I see those as all positives. If you are somebody that's burned, for instance, and the traditional way is to make a burn mask, which is, a plaster mask that lies right on the burn victim. It's very painful, number one, to make that. It's a very slow process. And also, it distorts the body. So the new way is, if you are burned or you're in a bad wreck, and if every single hospital had a body scanner, like a surface scanner, not a CT scanner, but a surface body scanner, then this surgeon who's never seen you before can actually subtract swelling and can get down to a place where he's got a template to work on to help recreate your face, for instance, or if one side of your face is damaged and the other side is not, they could mirror it and just have a really head start on helping people. And, so that's, I see those as really amazing. And you're not, and they're comfortable. These surgeons today are very, very comfortable working in 3D. We do a lot of medical devices. We do a lot of body parts. If you think about how to get someone's body geometry in the computer, the easiest way and the fastest way is to scan them.
Right.
So, yeah.
Makes a lot of sense. Very exciting stories, very exciting technology. This has just been, I could sit here and listen to these stories all day long. And I think that you guys have many stories that people, you get articles out, you've got lots of attention because of these amazing stories.
Well, we really enjoy the work. I mean, I think that we're unique in the sense that we work in such diversified fields, and it certainly keeps you from getting bored.
What do you think is the biggest reason? What's your why? Why do you think you're so driven to be? And I really believe that 25 years ago, I'd imagine most everybody told you that you're crazy to go in this industry, but you had the drive. There has to be something. There's got to be a why, I would think, that's driving you.
It was just so cool. I mean,
cool.
It was just like the Starship replicator. I couldn't believe it. And you know what? It's still just so cool.
Oh, I love it.
That's it. I mean, I love the way that people think about how to use this stuff. I mean, and that just is a driver for me.
Starship replicator. Yeah. I love that. That really tells the picture.
And I kind of just altruistically think that these technologies, and coupled with the internet, might just be the great equalizer in the world, for all of us to really just understand that we're all the same species, and we're all the same type of people, that we all have the same kind of dreams, and we all basically want the same things. And I think that these are things that can be happening. I mean, sending data around the world. We work with clients from all over the world, and it can happen instantaneously now. And, I think that those are really huge, good things. I've always believed that. I mean, and I still believe that.
I concur. I think, and a lot of people will definitely disagree with me, but I believe we're at one of the best times in the world. I don't just allow my kids screen time. I believe computers and the devices and the technology is an equalizer, and it's a positive thing. Are there negatives of it? Of course, we can find positive and negatives of anything. But I've come to the conclusion that we're technologically moving forward. We're never going to go back. And so I'm all in, and I'm pretty excited about it. And I do think that it's more positive than anything.
Yes, and I mean, I would agree. And I like to really remind people that these are tools. They're just powerful tools. And the more tools you have, I think that's a good thing. I mean, right. There's balance in everything, but I mean, we can't create art without the sculptor. We need the sculptor. So it's a great marriage between the sculptor and tech.
So that's where I really believe, and one of the reasons I'm so excited about where we're at today as a world, is that I really believe that art is becoming the center of everything, from technology to where we're growing as humans and equalizers, and trying to get all the people together. To me, art is becoming one of the center points, and I've never seen that or felt it until recently.
And I think, I mean, you can take that art and translate that right over to the automotive industry or right to the aerospace industry. Because when you look at the products that they're creating, it is art. It's another form of art, and it's beautiful. It's things that weren't done that well before, and these are the tools that allow an engineer or an industrial designer to create their art.
Exactly. And they're becoming artists, and I feel, encompassing it all as art. Whereas it might have been 30 years ago art, but we didn't really, as a culture, encompass it as art. And now we're starting to realize that stepping outside the box and allowing every person's creativity all the way to the engineer is just becoming more of a common point. And I think it's very exciting.
I do too. I mean, surgeons, every person that walks in here, we work with some inventors that are just creating things in their garage, and they've got a vision. That's how the PC
was created.
That's right.
So I love it.
They've got a vision, and they put in the time, and they, we're there to help them make it happen. And if there's something, that we can draw from some other industry we worked in, we always try to offer that if they want. And what I see often is that people work within their industry, whether it's film and entertainment, or engineering and industrial design, or art and cultural heritage, or medical device makers, and everybody kind of is trained to kind of stay in their lane. And we find that there's tremendous crossover, but even with a lot of the tools that they themselves use. Animation and film was really the first early adapters to using 3D, obviously, but CAD and engineers really do a lot of the same type of work, and a lot of their tools actually parallel each other, but those industries never cross-pollinate. And we are in this fortunate position that we've got a lot of experience working with different types of industries, where we say, hey, have you heard about this? Have you ever tried that? And maybe this would work for you too. And they often do. Or we can pull ourselves tools from our own toolbox with cross-pollinating on their behalf. And, and there's just a lot that everybody can learn by thinking outside the box. And
absolutely.
Bring, guaranteed success, hopefully. That's our job. We like for you to succeed.
So we were just talking about the creative and the art side, which for me is one of the most exciting things for today. And you were just discussing that. Yeah.
Well, so and just keeping things in the digital end, I think is amazing, because once something is digital, you can make it bigger, you can make it smaller, you can offset it, you can pull dimensions, surface area, you can inspect it, you can do computational fluid analysis, you can do finite element analysis. You can just learn so much. There are just so many tools now that let you critique and learn from 3D data, and I think that's all really important stuff. I mean,
how many manufacturers, as you just went through that, some great technical opportunities, how many manufacturers out there you think are not getting it, that don't realize that they have this technological advancements that they could use, but they just don't know about it? They're not in the know. Do you think that that's still part of the manufacturing going on?
Well, I'm sure there are still people doing traditional manufacturing, but it's changing, and it sort of depends on the industry. I think aerospace and automotive are very savvy, and they are using it pretty routinely, whether they've got technology in-house or they work with a supplier like us. Furniture, there's still quite a bit of furniture made traditionally using 2D drawings. But scanning is really coming on strong. And there are different types of scanners out there, and there's even a little scanner you can get for your iPhone now, and it's kind of rudimentary, but it's fun, and it just helps spread the word about it, and It gets people inspired. And 3D printers are really have come all forward very, very quickly. In fact, 3D printing came on after scanning, and it's probably progressed faster. I mean, and so once you start with a 3D file that you put into a 3D printer, you either build it from scratch in an animation or a CAD program, or you scan something. And then once that's in the software, that 3D file's in the software, you can just print it out in a variety of materials. So schools, lots and lots of schools have 3D printing programs. The first ever kind of what I would call more holistic approach to 3D scanning, reverse engineering, and the intersection between that and CAD has just started at Cal Poly here in California. And that's the first program that I know of where they're finally teaching these skill sets in college. So, and I fully expect that to populate across the world, really, because these technologies are here to stay. I mean, and they are a skill set that most kids, if they choose that, and certainly if you're in any kind of an engineering or industrial design, or even an art, or anything, cultural heritage, they all incorporate them now. So, I see that as the future for sure. The future is here. It's not even the future.
The future is here. We are living it daily. Yeah.
Yeah, we are living it daily. And it's kind of fun. I mean, I guess the average person doesn't know that much about it, but there are some very, very cool things happening. I mean, very, very fun. They're doing some shoes now, which are 3D designed and, 3D printed. Clothing. I've seen dresses that people have on at some of the conferences where they're touting their design, and I think that's just fabulous. I really do.
Homes being built
Homes
with
being built.
3D printers, which is
absolutely
incredible. Yeah,
and almost any material you can possibly think of, resin and concrete and plaster and chocolate and just about anything you can think of. I mean, they're even starting, I'm happy about this, to do some recyclable materials. So they're, rather than us generating more plastic in the world, they're starting to get conscientious about that and making these types of materials so that they can be recycled.
That's a great thing, because I know that recycling has had its ups and downs, and the more that we think about it forward, it's the only way to really resolve it.
Exactly. Yeah, exactly.
So that makes a lot of sense. And I can see a lot of huge opportunity to make things recyclable that way, and with the application in mind before you design the product to start with as a recyclable product.
Absolutely. Yeah, absolutely.
In 3D printing, I can imagine, is going to be one of the largest opportunities for recycling.
I hope so. Yeah, I'd like to see that. I mean, and the materials are just getting stronger. They're changing all the time, and I don't know. Do you know how 3D printing works, or?
I'm not. I mean, I think I have a decent understanding of it, but I would love for you to explain it. Now, I have some computerized numerical background. I was actually taught in Fortran.
Oh.
And so I think I have a conceptual idea, but to put that into words is a whole nother ballgame. I think I can, conceptually understand it, but I would love to hear your...
Sure. So it's kind of cool as well. So you start with a 3D file, and that file is created by either scanning or from scratch in a CAD package, or it could be an animation package where you've created a creature or something. And then that file is input in the software, and it's sliced, typically in 1/4 millimeter layers. And then a 3D printer works like a desktop ink printer, in that it's got lots and lots of nozzles inside of it. And so the nozzles spit out the material, and it follows the outline of that slice file that it just made.
And I'm just trying to visualize it. So it will create what you said, what millimeter?
It's a 1/4 millimeter.
1/4 millimeter. So it'll create a 1/4 millimeter layer, and then start another one and kind of just keep on layering.
Yeah, it's an additive process. And so it can be a resin, and then that resin is a photopolymer resin. So it's solidified by a laser as the printer heads spit out that material.
So it
gets
hardens.
solidified. Yeah,
Right.
exactly.
And traditionally, the way I know resin is that we have to mix a hardener in it over a certain amount of time, and then it'll harden. But what you're saying is in the 3D printing, they have it timed so it starts to harden as soon as it's applied.
That's right. And there's also powders that are 3D printed that get fused. It's a fused deposition modeling product. It's still additive. All of these types of
like
technologies are
fusion
additive.
or
It's usually a chemical reaction.
Okay.
Yeah. And
Incredible.
yeah, and you can vary the layer thickness, and the machines, depending on the material and the machine you're using, that layer thickness will vary somewhat. And there's different levels of very, very fine builds where you don't see much in the way of any kind of build line. And then there's some coarser builds where you will see some build lines on a part. But the way the 3D printing industry came about was through the manufacturing industry. And manufacturers traditionally would have to go through the entire process from design to creating a tool, to creating a mold and a tool. And that can be, hundreds of thousands of dollars sometimes. And then the tool's created, and not until you start pulling your first parts out of that tool do you actually know how well you've done all along the way. And so 3D printing was developed to sign off on design intent before committing to very expensive tooling. So you could check your product beforehand. And in some cases, with some of these materials, it's not just fit, but you could actually put a boat prop on a boat and try it out to make sure that you've got.
Because a boat propeller has an amazing amount of effect. It's a small thing in comparison to the whole boat, but knowing that industry really well, it will affect how the boat rides in so many ways.
Exactly.
It is just a nick in a prop will affect it. So the pitch and how it's designed in every way really can make the boat shake, vibrate. It's incredible how it has to be spot on.
Has to be spot on, and you can put every safeguard into your design process as possible, including taking a 3D design and putting it into fluid dynamics software and testing it. However, until you actually have that prop on a boat, you won't know for sure. So that is really why 3D printing came about. Was the manufacturing industry, and they have continued to push the makers of 3D printers to get better and better materials, and they're doing that. materials that have greater structural integrity.
Wow.
So yeah, it's kind of cool. I mean, is it right now you can create a lot of replacement parts. We've actually done some quite a few legacy yachts recently, and they had some details on the yacht that were missing. There were these little, I call them finials, that look like pineapples, that were just details on the inside the cabin, and some were missing. And so we scanned an existing one and then created those in 3D prints, and the 3D prints were plated to match, and then put in the yacht. So that was kind of fun.
Incredible.
Yeah.
So the one thing I've heard you say that I want to just put back on you, and that is that you're real wise. This stuff's cool. Well, I got to tell you, Lisa, it's been cool just having this conversation with you today. It is very cool stuff.
Thank you. It's fun. I mean, I get excited.
Yeah, definitely. I can tell. So I think that we can wrap this one up, and Lisa, I just can't tell you how much fun it was to be here and get to listen to you and some of your stories and where your company's going. I really see you and Scansite 3D just being one of the most innovative and really impactful companies out there. It's been just a great time, and I can't tell you how much I appreciate this time with you.
Well, thanks, Rex. Thanks for having me, and I'm always glad to share. So thanks for coming over.
Oh, anytime.
Yeah.